In this video, I'd like to walk you through a fairly easy way to do conversions between a binary number and a decimal number. Now, sometimes I hear the argument, oh, Keith, I really don't need to know this, or I don't want to learn this. But you know what? If you follow my instructions that we're going to do right now, this is actually a fairly straightforward, easy process to do. And I guarantee it, you're going to want to have this knowledge in your hip pocket when we get to variable length subnet masking. So let me walk you through an example of converting a binary number to decimal. So this represents right here an IPv4 address. So this part is the mask represented in CIDR notation. And it simply means that the first 24 bits, I'll go ahead and highlight them here. These first 24 bits represent the street name or the network ID, because the network ID very much is like a street name. And because the mask said the dividing line ends at the first 24 bits in, that means these 8 bits over here on the right-hand side are like the house address, or the house number, or the host ID in the case of an IP network. So the question is, if you ever needed to, for any reason, convert these binary numbers over to decimal, how do we go about doing that? Also, for convenience, I added a little space here. So I added a space here between these first 4 numbers and the second 4 just for readability. That's the only reason I put it there. So that little space is just me making it a little bit easier to read. So we can handle 4 bits at a time, but just realizing all the bits here in this color are part of the first byte in the IPv4 address. All right, so I'm going to go ahead and take away the mask just for a moment so we can focus on the conversion of this binary number to whatever the dotted decimal equivalent IP address is. And to do this, we're going to do it 1 byte at a time. And also to do this, we're going to jot down the values of the decimal values of each of those bits in that byte. And the way this works is this is the ones position. And then because it's base 2, you just do a times 2 for that value, and then times 2 again for that value, and times 2 and times 2 and times 2. And you could actually go higher than 8 bits, but there's no need to. So if you go 128 times 2, it'd be 256. But we don't need to worry about that because we only have 8 bits to play with. This is the ones position from a decimal perspective, 2s, the 4s, the 8, the 16, the 32, 64, and 128. So to convert a number like this one up here into dotted decimal, we take 1 byte at a time and just write the values out. So we'd write this chart out, which is really easy to remember. Just start with 1, and then times 2, times 2, times 2, times 2. And even though I have a few certifications, and a couple of those are CCIE, expert level with Cisco systems. But if you watched me take a test, and they had scratch paper and stuff to use, you'd see me write out these values whenever I'm doing any type of subnetting questions, because I just don't want to make an error based on what I think it's going to be. I want to actually do the math. So I would encourage you, whenever you're doing conversions from binary to decimal, just to write out the values, the decimal values of each position in 1 byte of data. And again, you start on the right and just keep doubling until you hit 128. Or if you want to start over here and just divided by 2, divided by 2, divided by 2, that works as well. So then you take 1 byte of data. We'll take this first byte of 1, let me put it in the right color here, 1, 0, or close color anyway, 1, 0, 0, 1. That's the first 4 bits, and then 1, 0, 0, 0, 1, 0, 0, 0. And then we take the decimal value for the bits that are on and we add them up. So we take a 128, and there's no 64s, no 32s. We have 116, 18, no 4s, no 2s, no 1s. So 128 plus 16, we'll do this longhand. 128 plus 16 plus 8 more. So 8 plus 8 is 16 plus 6 more, be 22. Carry the 2 there, bring down the 2 there. Then we go to our next column. So 2 plus 2 is 4, plus 1 more is 5, and a 1 here to be 1. So boom, this first octet here has a dotted decimal value of 152. Now, if you're saying, oh, this game seems pretty simple, but I need a few practice sessions to get it right, good news. We've got a few more practice sessions right here because we do the same thing for the second octet and the third octet and the fourth octet to find out what the dotted decimal value is for this IPv4 address shown in binary. So we'll do a little cleanup here, and let's go for our second byte, and I'll color code that in blue. So for our second byte, that's 0100, 0100, and then 0011, 0011. Then we add up the values that are on. So there's no 128s, there's a 64, no 32s, no 16s, no 8s, no 4s. We have a 2 and a 1. So we just add up 64 plus 2 plus 1, and that is 67. So that's the value in decimal of our second octet here in the dotted decimal representation of this binary address. All right, we have a couple more, so let's go ahead and clean that part up. And let's do our next one, which is this third octet right here in green. So its value is 0, 1, 0, 1, that's the first 4 bits, and 0, 0, 1, 1. And then we just add the values that are on. So 64 plus 16 plus 2 plus 1. We'll do it longhand here. 64 plus 16, that's a 0. That'd be 80, carrying that 1, plus 2 more, plus 1 more, and that's 83. So we'll put that right here. And then we have our last octet, and that is 01101100. We'll clean up our work here from the previous one, and we'll do our last octet here in the same color, which is black. So we'll do a 0110, that's the first 4 bits, and then 1101, and then add them up. So we have a 64, no 128s, no 16s, no 2s. So 64 plus 32, that'd be 96, and then plus 8 and 4, that's 12 more. So if you do the math there, that's 8 and 100. And then we have the 1, so that'd be plus 1 more, that's 109. And that would be our last octet. So that, my friend, is how we can take a binary number, 1 byte at a time, using this little table right here, plugging in the binary value and then adding up the value positions, the decimal value positions of each of those bits, and then that sum is going to be the value for the respective octet. So we could say that this IPv4 address, which is really hard to read with the naked eye, it's really the dotted decimal address of 152.67.83.109. And as far as the dividing line, that's up to the mask. So we'll cover that a little later, but if the mask says it's a /24, that means the first 24 bits are the network and the last octet is the host ID. If the mask says it's /16, that would then mean that the first 2 octets, the first 16 bits, represent the actual street name or the network, and then the last 2 octets would be host addressing. And as I mentioned, the mask could be represented like this, the CIDR notation /16, or it could be shown as 255.255, which is the first 16 bits all being on in the mask value, and then it could have 0.0. So /16 or 255.255.00 mean the same thing. The first 16 bits are all being identified as network bits representing the network ID, and whatever's to the right of that is host addressing. Again, think of it like the street name on the left portion of the IP address, and then based on the mask dividing line, the house address or the host ID being on the right. So now that we've identified without a calculator how to convert a binary octet of data over to decimal by using this method right here, in the next video, I'd like to give you yet another important tool to tuck in your tool belt, and that is the ability to take a decimal number and convert it into a binary octet or 8 bits. So I'll see you in the next video for exactly that. Hey, thanks for watching, and subscribe right here to get the latest information from CBT Nuggets. And if you're new to or considering a career in the world of IT, head on over to CBT Nuggets and sign up for a free trial.